I gave you this problem at the end of the last video. I hope you had a chance to try this before watching this video, but let's work through this now together. So I'm taking the third power of x squared plus 2x. So all of my terms are going to involve three factors, each of which is either an x squared or a 2x. So I'm going to have some copies where all three factors are x squared. So that would be x squared to the third power. Plus some copies, now I'm going to have one less power for the x squared. So x squared just squared, and then I'll have 2x to the first. So the exponents still add up to 3. Plus some copies of one less copy of x squared, so just x squared to the first, one more copy of 2x, so 2x squared, plus some where I have no x squareds, and that would mean that all three factors are 2x's. To figure out these coefficients, I'm going to use Pascal's triangle. I think I'm going to write that up here. So I start with a 1 and a 1, move out, 1 plus 1 is 2. Move out, 1 plus 2 is 3, 2 plus 1 is 3. That's the third row, which corresponds to the coefficients for the third power. So I can now fill in 1, 3, 3, and 1. And again, the number of numbers in the appropriate row of Pascal's triangle should match the number of coefficients. If it doesn't, something's gone wrong. You're either looking at the wrong row of Pascal's triangle, or you calculated it wrong, or you don't have the right terms. All right, so now let's simplify. Okay. When we have a power to a power, remember we multiply those exponents. So that's going to become x to the 6th plus 3 times x to the 4th times 2x. I'll come back and combine all the numbers and the x's. Plus 3 times x squared. Now here, that exponent of 2 applies to both the 2 and the x because they're connected by multiplication. So 2 squared is 4, and then x squared. Plus here, I'm cubing the 2, so that's going to be 8, and I'm cubing the x, so that's x cubed. So then this is x to the 6th plus 3 times 2 will give me 6 x to the 5th plus 3 times 4 will give me 12 x to the 4th because I have x squared and x squared plus 8x cubed. So notice, once we simplify, the coefficients that we have in the end aren't just the numbers from Pascal's triangle. If there were numbers in either of our terms, those numbers are going to contribute to the numeric coefficients that we have at the end. So there isn't this pattern with the coefficients that I have at the end, but the pattern is in there. Those are the coefficients I have before I simplify my terms. All right, I want to take a look at one more here. And I'm going to have you folks try this one as well. Let's suppose I had 2x cubed minus 3 to the 4th power. Now here, my binomial is written as a subtraction problem. If you remember, in the very first video, I said we're going to view all of our binomials, for the purposes of this theorem, as a sum of two terms. In fact, polynomials are defined as sums of things, where we incorporate subtraction as just adding a negative term. So before I work this out, I would need to rewrite this as 2x cubed plus negative 3 to the 4th. So my terms are not 2x cubed and 3, they're 2x cubed and negative 3. Okay, so with that as a start, go ahead and see if you can work this one out. That negative is going to make some of the terms in your final answer end up negative and some will end up positive. That's okay. Try and work this out. We'll go over it together in the next video.